Many bacteria grow on glucose before they utilize other compounds, such as lactose. Many bacteria grow on glucose before they utilize other compounds, such as lactose, as a growth substrate when both are present in the medium. Transcription of the lactose operon is controlled by two regulatory proteins. The catabolite activator protein can bind to the activator binding site and facilitate transcription, and the lac repressor protein can bind to the operator site and block transcription. The catabolite activator protein can bind to the activator binding site only if cyclic AMP is bound to it. When glucose is present, the concentration of cyclic AMP in the cell is low. RNA polymerase cannot bind efficiently to the promoter, and transcription does not occur unless the catabolite binding protein is bound to the activator binding site. Therefore, transcription of the lac operon does not occur in the presence of glucose. In addition, if there is no lactose in the medium, the lac repressor binds to the operator site, and this blocks transcription. When both glucose and lactose are present, there is insufficient cyclic AMP to bind to the catabolite activator protein, which therefore cannot bind to the activator binding site. Without the bound activator protein, RNA polymerase cannot bind to the promoter and initiate transcription, even though lactose binds to the repressor and prevents it from binding to the operator site. When neither glucose nor lactose is present, the concentration of cyclic AMP is high, and the catabolite activator protein is bound to the activator binding site. RNA polymerase can bind to the promoter, but it is blocked by the repressor on the operator site. When glucose is absent and lactose is present in the medium, cyclic AMP is present and binds to the catabolite activator protein, which in turn binds to the activator binding site and facilitates transcription. Lactose binds to the repressor and prevents it from binding to the operator site. RNA polymerase can now bind to the promoter and carry out transcription.